So today, we're still going to do some probabilities where we're going to have to do some adding, but there are going to be some things that we're going to have to take into consideration when we do our calculations. So we're going to do sort of our own little survey right now. There's a couple people asking, but it should not affect the results of this survey. Simple question. Raise your hand. No, it's not a question. Thank you for participating. So I didn't finish. I was going to say, raise your hand if you have a brother. I'm just going to count how many people have brothers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23. Okay. So in this class, 23 people have a brother. Now raise your hand if you have a sister. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 4, 5, 6, 7, 8, 9, 29. How many people are in this class? Wait, I got 36 desks. 1, 2, 3 empty desks. So there's 33 people, right? What do we get when we add these up, though? 52? So how's it we're getting 52 when there's only 33 people in the class? Okay, and that's the most important thing that you need to learn today. Is the idea of double counting. When we do probabilities, we got to count things up, right? There's going to be times where we have to do multiple probabilities, but you're going to end up double counting something. And when you double count something, it affects your probability. Because remember, our probability has to be between 0 and 1. If you double count something, you could end up over 1, and that's not allowed. So this idea that I'm telling you about, this idea that I'm talking about is called mutually exclusive. This is the most important thing that you need to learn today. Mutually exclusive. It is going to determine how you calculate using the formula that I'm going to give you. So let me give you an example of what mutually exclusive means. And it's weird that I'm going to do this. This right now, it's like it's not positive, it's not negative, it's just like it's neutral. But every definition I'm going to tell you uses the word no. No double counting. No sharing. No overlap. Every single one of these things that I'm writing down means the same exact thing. Doesn't belong in both groups. So the thing that was tricky for second hour is you see how all of these are negative? It says don't do this, don't do this, don't do this, don't do this, but then it's called mutually exclusive. My second hour got all mixed up because I gave them a scenario and there was no double counting, so they said, oh, that's not mutually exclusive. It's actually backwards. When there's no double counting, it means that it is mutually exclusive. So the first thing we need to do is make sure we can tell if something is mutually exclusive or not. I haven't showed you the formula yet, but it's going to determine, well, I should back up a little bit. There is a formula. There's actually two different formulas. There's one formula for mutually exclusive and one formula for not mutually exclusive. I don't want you to know both of them. I'm just going to make you learn one of them and understand that if it's not mutually exclusive, one part of the formula is just 0. So that way we don't have to memorize different formulas. We can just learn one. So we're going to go through these different scenarios. Oh, you know what? I'll say this also. Does not happen at the same time. Okay, that's another one. But again, notice how all of them are like negative. No double counting, no sharing, no overlap, does not belong to both groups, does not happen at the same time. That's what mutually exclusive means. So when I give you this scenario that has a couple of events, I want to know, could those events both happen at the same time? So here's example number 1. It says a spinner. So you guys have seen the spinner. We did the one with the different colors the other day. Except this one is numbered from 1 through 8. Here's the two events. You're going to spin the spinner and try to get a 3 or a 6. Is it possible to get 3 and 6 at the same time? No, it's impossible. So that means this one right here. Whoa, sorry. I almost messed up. Is mutually exclusive. It does not happen at the same time, so it is mutually exclusive. So here's another one. It says a magazine contains 12 pages. You're going to open it up to a random page. We're going to try to find the probability of landing on page 8 or page 10. Is it possible to land on both page 8 and page 10 at the same time? So there's no doubles, right? Didn't happen at the same time, so it is mutually exclusive. Okay, the next one. It says a bag contains 6 yellow jerseys and they're numbered from 1 to 6. The bag also contains 4 purple jerseys and those are numbered from 1 to 4. You're going to randomly pick a jersey, and here's our two events. We want to pick a purple jersey, or we want to pick a jersey that has a number bigger than 5. Is it possible in this paragraph to get a purple jersey that has a number bigger than 5 on it? No, because purple is only numbered 1 through 4, right? So this one right here, it is mutually exclusive because they do not happen at the same time. So it's a weird concept because it seems backwards. You would think that if you answered no, you would think it's not mutually exclusive, but it's actually the opposite of that. Okay, here's another one. A box of chocolates contains 6 milk chocolate and 4 dark chocolate. 2 of the milk chocolates and 3 of the dark chocolates have peanuts inside. You randomly select and eat a chocolate. It is a milk chocolate or has no peanuts inside. Is it possible to get a milk chocolate with no peanuts inside? Yes. So that means this one, and this is weird, right? The answer to the question was yes, but we say it is not mutually exclusive. So what you guys are going to have to learn is it's like the opposite. If you're asking yourself, does it happen twice at the same time? If the answer is yes, then you write not. If the answer is no, then you say it is. So I want you to be extra clear with that because that's what was messing up second hour when they got to the assignment. So now I'm going to show you the formula, and I'm going to sort of explain to you that most teachers and most textbooks will give you 2 different formulas. They will give you a formula for mutually exclusive, and they'll give you a formula for not mutually exclusive. But I'm just going to give you one because I'm going to explain to you what happens with mutually exclusive. So in this general addition rule, it states if you want to find 2 probabilities, that is an OR problem, because that's the key word here. So the stuff I'm teaching you today is only for when it says find the probability of this or this happening. It says if you want to find the probability of this or this happening, just find each individual probability and then subtract. This part right here means that they are both happening at the same time. That's what that part means. Now here's the catch though. Here's why I don't want to teach you 2 different formulas. Sometimes that last part is going to be 0. So if you have something that is mutually exclusive, that means there is no double counting, then you subtract nothing. So sometimes right here, I'm going to make a little note. When this part equals 0, That just means it's mutually exclusive. Now, we're actually going to do it backwards, though. When we do our formula, we have to decide first if it's mutually exclusive or not. Then from there, we'll know what to plug in. Mutually exclusive means this part right here of the formula is going to be 0, which means you can just ignore it. So if two things are mutually exclusive, all you have to do is add up each probability, because subtract 0 does nothing. So we're going to go through, and we're going to see if there's any, if these events are mutually exclusive or not. So let me show you this illustration right here. I'm going to use the deck of cards as a visual to see what mutually exclusive means. It says, what's the probability of randomly selecting a spade or a heart? So the key word here is or. When we see the word or, we have to decide, is it mutually exclusive? So here's a great visual to tell if it's mutually exclusive. So we want to find the probability of selecting spades. Here's all my spades. We want to also find the probability of selecting hearts. Here's all my hearts. When I calculate these probabilities, is there any double counting going on here? No, there's no overlap. So when we do this, there's two ways you can do it. First, find the probability of a spade. How many spades are there? There's 13 out of 52. 4 is plus. And then we have hearts. How many hearts? 13. So we got another 13. So, oh my gosh. So you could just add those up, and if you really wanted to, you could say minus 0, but it does nothing. So the answer to this is 1/2. These are mutually exclusive events because when we colored in this stuff, they didn't overlap each other. So that means none of the cards got double counted. I'll show you another one. Get rid of all this. Okay, the next one. What's the probability of randomly selecting a jack or a heart? So we've got, let's see, highlight. Where's my jacks? Jacks are right here. Get rid of that. And then we've got hearts. Here's my hearts. Do you see what I mean about double counting? How many cards got double counted? There's one card that got double counted. It's where the overlap occurs. This card is the double counted card. So right away that tells you it's not mutually exclusive anymore. So when we do the formula, we do each individual probability, but then we subtract the overlap. So probability of getting a jack, 4 out of 52, plus the probability of getting a heart, 13 out of 52, minus the overlap. There's one card that got counted twice. So guys, when it comes to cards, you just got to ask yourself, when they tell you the different cards, ask yourself, is there a jack of hearts? Yes, that means it's not mutually exclusive. Look at the other one. Is there a spade of hearts? No, there's no such thing. So that one's the mutually exclusive one. Oh, what's the answer? 3 out of 13? Oh, try to remember from second hour. So after you do all of your math and you reduce it all, it ends up being 4 out of 13. Now, I like the illustration because it really shows the overlap part. And I think on the test, it's a lot of card questions, or a few card questions. So we're going to go through this, and we're going to check to see if these things are mutually exclusive or not. So, oh, and the thing that I just showed you, it applies to multiple probabilities, not just 2. Like in number 1, that's 3 different events. Probability of getting a 3, a 6, or a 10. Is that mutually exclusive or not? Yeah, that's mutually exclusive. There is no overlap. When you color the cards, none of the colors are going to overlap each other because you're all going in the same direction. So this one right here is mutually exclusive. Mutually exclusive in the formula means the last one is 0. How about 8 or a club? Is that mutually exclusive? No, that's not mutually exclusive. So that one's our NME. Did you get it? Enemy?
Oh my God.
Sorry if I try to make my life fun. Okay, the next one says a face card or a diamond. It's not mutually exclusive because there are cards on there that have a face and a diamond. So this one is not mutually exclusive. Okay, and then the last one is ace or a queen. That one is mutually exclusive. There is no such card as the ace of queens. There's a TV show, King of Queens, but not deck of cards. Okay, so now that we've identified if it's mutually exclusive or not, we can do the calculations. Mutually exclusive means we don't have to subtract at the end. So you can just ignore the subtracting part. So the probability of selecting a 3, 4 out of 52, plus the probability of selecting a 6, still 4 out of 52. Probability of selecting a 10, 4 out of 52. What does that reduce to? 3 over 13? Yes. You guys don't know it, but I was right in my head. Okay, the next one. Probability of an 8. 4 out of 52. Probability of a club. I have another dumb joke. Okay, ready? Probability of a club? Well, it is going to be Friday night. Yeah, you know what's up. Okay. Clubs. There's 13 clubs out of the 52. And this one was not mutually exclusive. So how many cards overlapped? Only one. There's an 8 of clubs. So we subtract 1 out of 52. So what's that one? What is it? 4? 4 out of 13. Yeah. 4 out of 13. Okay, the next one. Oh, this is a good one. Maybe I should highlight this one. Probability of a face card. How many face cards are there? There's 12 of them. 12 out of 52 are face cards. Plus the diamonds, 13 of those. And then I think I will highlight. So let me go highlight all the face cards. Highlighter, face cards, here, here, and here. And then, what was the other one? The diamond. So all the diamonds are right here. So what do we need to subtract? Yeah. So we subtract 3 out of the 52. 22 out of 52, so 11 out of 26. Okay, probability of an ace, there's 4 of those. Probability of a queen, there's 4 of those. And it's mutually exclusive, so you could subtract 0 or just leave the end blank. 2 out of 13. Is this making sense? Okay. So the last thing that I want to talk about, though, is you're going to have to know how to tell just by looking at the actual probabilities whether or not it's mutually exclusive. And it's actually very easy to tell. In the formula, if you have a number, if you have an answer for the and part, it's automatically not mutually exclusive because and means they're both happening at the same time. So when you look at the formula, you can tell right away if it's mutually exclusive or not mutually exclusive. Mutually exclusive means and is equal to 0. Not mutually exclusive means that that is an actual number besides 0. So watch this. And I mean, as confusing as it sounds, it's really just substitution. So they want you to find this probability. We could use the entire formula and just substitute in the numbers and determine what the answer is or whether or not it's mutually exclusive. It's really easy. So watch this. The formula says, if I want to find the probability of two events happening, that is equal to the probability of one event plus the probability of the other event minus the probability of both events happening at the same time. Straight up substitution. They gave us 3 numbers, and I got 4 parts right here. So let's plug in what we know. Do I know the probability of A or B? Actually, I don't, because if I did, it would have said A or B equals this. I don't see an A or B right here in the blue. So I don't know that one. So that one stays. Probability of A or B. Do I know the probability of just A? 0.2. Probability of just B? 0.65. Do I know the probability of both A and B? 0.3. So guys, like we've talked about before, in any formula, there's going to be like unknowns, and then they're going to tell you like, if there's 5 unknowns, they'll tell you 4 of them. If there's 3 unknowns, they'll tell you 2 of them. It's our job to find the last one. So same thing. There's 4 parts to this formula. They gave us 3 numbers. So all we have to do is plug it in and find the last part. Luckily, they all ended up on one side, so there's no math to do. What's the answer? Loud? Thank you. What I did right there is called wait time. They teach you that in college. You just wait until you get the answer you want. It's pretty fun. Okay, so here's another example. It says, are the events A and B mutually exclusive? Let me go back to the formula one more time. Remember right here, I said if it's mutually exclusive, the end is 0, right? So basically what that means is the probability of A or B should equal when you just add up each individual probability. There should be no other number affecting the sum of those 2 things. So let's see what they gave us. So they want to know, is the probability of A or B mutually exclusive? So probability of A or B equals probability of A plus the probability of B. And there's another part to the formula, but if it's mutually exclusive, that part's just 0. So if this is truly mutually exclusive, these things should add up and they should be the same number on both sides. So do I know the answer to A or B? So there, look at 0.7. Part A, or probability of A, 0.1. Probability of B, 0.6. So we end up with 0.7, 0.7. So the answer, yes. Now, if these didn't match, that just means that there's I can't say the word. There's some subtraction happening that's making them not equal anymore. So if these don't match, then now that's not mutually exclusive. Now, the whole topic for today has been about mutually exclusive. And I defined it as no sharing, no double counting, no overlap. I want to show you what I'm talking about when we talk about overlap. These things right here, and we're going to have a whole lesson on this, but these things right here, they're called Venn diagrams, and they show us relationships between things. There's going to be one question on your assignment that's going to ask you to look at a table and put the numbers into the Venn diagram. So let me show you first how to read the Venn diagram. I can figure out a lot of stuff from this Venn diagram. So I could figure out the probability of just A. So when I'm talking about the probability of just A, and let me also say this. I learned this from a workshop I went to with the lady that's the head of the, she's over at ASU West, and she was, I forgot what her title was, but she was basically the person in charge of probability. Like she was the main lady to go to when it came to probability. So what she said was, you guys know the little thing that the toilet paper's on, the little cardboard thing, or like wrapping paper? She said when you look at the circles, imagine you're holding, and she actually did this in her college class. She saved the toilet paper roll, the end of it, and she had them put it around the circle. So what's the probability of A? You see how it's not just 0.3, right? It's 0.3 and 0.2 together. So the probability of A is 0.5. This entire circle adds up to 0.5. That's just probability of A. What would the probability of B be? That would be 0.6. And if I wanted to know A and B, yeah, that's the 0.2. That's your overlap. So when we talk about overlap, that's what we're talking about. So you could find the probability of A or B by using the formula. 0.5 plus 0.6. So just think about that part. What's 0.5 plus 0.6? Type it in real quick. 0.5 plus 0.6. It's 1.1. Are we allowed to have numbers like that in probability? So automatically you should know that this is not mutually exclusive. We went above the threshold of 1.0. So that right there should tell you automatically that it's not mutually exclusive, and we have to subtract to get back to 1 or under 1. So we would do 0.5 plus 0.6 minus the overlap. So we would subtract the 0.2, and that would take us back to 0.9. And all that stuff is right here. I just said it out loud, but it's all written right there, and it's all explained. But I wanted to give you sort of like a preview to this Venn diagram stuff, because there is one. You don't have to calculate anything. You just got to be able to put the numbers in so everything adds up right. And that's it. So today is basically about mutually exclusive. Mutually exclusive. No sharing, no overlap, no double counting. If there is any double counting or overlap, you have to subtract it. Otherwise, you could end up over 1.0, and that's not allowed in probability. Isn't probability dope? I like it. It's fun. I used to not like it. Like, I took a whole class on probability, and I was like, what are they talking about? They had us writing computer programs, and so I just joined a group and had them do all the work. I put my name on it because I didn't know what they're doing. But they had us do this computer programming stuff where it would calculate probabilities for us, but I don't know how to write code, so I don't know what they were doing. I must have been in the wrong classroom. That would have sucked. Okay, so you got about 20 minutes to practice and get good at mutually exclusive. I'm going to be walking around to make sure. Guys, the log test was supposed to be the easiest test of the semester. I think this probability test could be a tie. But you have to, if you're going to do good on it, you really have to know what mutually exclusive and not mutually exclusive is.